Oh, here. I have to hide my expos.
Okay, I think all of you guys know me, but in case you don't, I am Mrs. Woodward. And I am so lucky because today I get to come in and do some math with you guys. Okay? And I'll try to learn y'all's names as we go, but most of y'all know I always forget names. So I will do the best I can with that. So first, I'm going to start with our number talk. And sometimes, first of all, I'm here today because I'm learning to be a better math teacher. Y'all are learning to be better at doing math also, right? And teachers, we're always learning also. So I'm learning today, so sometimes today, I might kind of pause what I'm saying to you, and I might ask Ms. Burke a question, or I might tell her something I'm thinking, because you know how we think while we do things? Teachers do the same thing, we're thinking. So I might tell you, hold on just a minute, and have a quick conversation with Ms. Burke while I'm learning today. We might have a conversation, okay? Awesome. Well, I would like, mind if I scoot it up? I'm a stander. Okay. Oh, actually, before I do this. So I'm sure y'all do the same thing, similar to what I do in a number talk, but I just want to review with you guys the signals I use in a number talk so we're all on the same page. So when you have an idea on a number talk, what do you do? Awesome, perfect. And after you have one idea, do you turn your brain off? No, keep our brain going. So what do we do when we have another idea? Yes, mathematicians, writers, readers, we keep coming up with ideas. Now, has anyone ever had kind of an idea, but you're unsure about it? You're kind of confused. I have that happen a lot. Kind of an idea, but you're unsure. You can give me a sideways thumb. Perfect. Now, what if you agree with something someone else is saying? Oh my God, y'all are so amazing. Perfect. Yep. Not me too. No, just I agree. Perfect. Okay, I'm going to give you a problem. I want us to think about this. We're going to talk about potential answers, and then I want us to think about as many different ways as we can to think about how we can solve this. So once you have an idea, okay. What are some potential answers?
27.
Any other ideas? Any other potential answers? Today we all agree that's the answer? Okay. Now, I want to hear lots of different ways of how we could picture this in our head to solve this. So what are some different ways you thought of it?
Equal groups.
Okay, describe that to me.
So I drew 3 circles
Okay,
and put 9 in each.
okay,
And then I added 9 plus 9,
okay,
and that equals 18.
okay,
And then I put 9 down.
okay,
And then 18 plus 9 equals 27.
okay. Anyone else do it that way? How did you do it?
Number line.
Oh, talk me through that.
I did 3 hops of 9.
Okay, so kind of like this, you hop to 9, and then, what's kind of another word? What was the next hop going to get you to?
18.
This is a great representation for something else. What is that called when we kind of hop the numbers like that?
Skip counting.
Yeah, great representation in your mind of skip counting. Great. What's another way we can solve this problem?
I did something that was similar to the equal groups, but
Okay.
instead of having 3 groups, I did 9 groups.
Okay, so like this, but you did more circles with 3 in them? Great strategy. Got it.
You can also build an array.
I'm going to have to erase some of this. I want to talk about that array idea. Okay, talk me through that. What does that look like?
So you do 3 rows.
Okay, so like this.
And you do 9
Like that.
And then you multiply them.
Okay, so one does that look
3
like?
times 9.
Okay,
And then, or you can put 3 down.
okay, like this.
And then 3 times 9.
Okay, so you could almost kind of count it up. You could know your math facts and know that that equals 27. Great. Everyone turn to your shoulder partner right now and try to come up with 2 more ways to solve this really quick. Beyond what we've done. See if you could come up with 2 more ways. Really thinking outside of the box. You think of any other way to solve it?
Skip counting. I thought the names. Counting by 9 or 10.
What do you think about that? Do you think you can count by either of those numbers? Okay, come back. Whole group a minute. Okay. I heard some interesting things. I want to show you guys something that I've had some friends do in the past. Can we have a multiplication fact? We can use another fact to help us get to it. This is kind of hard to see. Y'all can tell there's how many columns, or here I could turn, how many rows in this one? So it kind of looks like what we had. How many? 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everyone whisper to me, what is 3 times 10? 30. Everyone knows our tens, right? Did you know that you can use a fact you know to come up with this fact? So think in your brain, how could we use 3 times 10 to help us solve this? How can we use that? Think, think, think. Turn to your shoulder partner and tell them, how do you think we can use a fact? Okay, everyone come back. Okay, awesome. I heard you guys say you could use the fact we know, 10 times 3, and we could subtract 3. Do you see how I just took 3 off of my array there? So in multiplication, if you ever get stuck, find a fact you know, and this is called building down. Build down. So did you share the array strategy? You could always build the array for the 10 that you know, and just subtract it. Take off the number. It's a great way to get to a fact. Uh-huh.
How I did it
Uh-huh.
was I just took 3 9s and I divided it into 4 and 5, and then I put it by 5, and then I know that
You took 3 9s like this. You kind of pictured 3 9s, and then what did you do?
I divided them into 4 and 5.
Like this.
Yeah.
Okay. Each 9. Okay. And what did you do?
And then I counted by 5s 3 times, and that was 15.
Breaking those numbers apart. Great.
And I counted by 4 3 times, and that was 12. And so I added 15 to 12, and it was 27.
Great. Another great, using another fact. So using your 5s to get there. Great. And now we are going to go on to problem solving. And I have a problem today that first I'm going to show you how I'm going to solve a problem, then I'm going to send you guys off on your own to solve a similar problem. So, my problem is, Judy covered a piece of paper with square tiles to find the area. So, picturing Judy, I'm picturing a person, picturing she has a piece of paper, and I'm picturing she has square tiles and she's covering it. What is the area of the paper in square units? and explain how Judy can find the area. You guys can't really see it, but it has a picture for me, okay? And it shows me what the paper is that she drew. And it has 4 rows and 1, 2, 3, 4, 5, 6, 7 columns. So I'm visualizing, I am picturing this piece of paper covered in square tiles. And I'm going to really pay attention to what it's
My name
asking
is
me.
Mike Gerardo, and I will be one of the watchdogs for the day. My kids are Andrew and Allie in 1st grade and 4th grade.
Good morning, Isabel. My name is Sean Baxter, and my daughter is Emily Baxter, and she's in 1st grade, and I'll be a watchdog for the day. Please stand up for the pledge and have an excellent day. Don't forget to show your Isabel pride.
I pledge
Allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Honor the Texas flag. I pledge allegiance to thee, Texas, one state under God, one and indivisible.
Yeah. Now we're gonna have a moment of silence. Okay, now let me sit.
Thank you. Okay, so I visualize it. I drew my picture out. Judy has this paper. It's covered in square tiles. I'm even going to go ahead and kind of write my measurements. There's 4 on this side, 7 on this side. What is the area of the paper in square units? I'm thinking square units is going to be one of these things. One tile is going to be a square unit. And I'm thinking, looking at this, that I actually know something that helps me find area. I can do length times width equals area. Do you know that? And that's just a very standard rectangle shape. So I think instead of, I could go and count how many tiles she has. 1, 2, 3, 4. But that's not going to be super efficient. So I'm going to go ahead and I'm going to multiply my length times my width. So I'm going to do 7 times 4 equals, that is not a fact I just know off the top of my head, so I'm actually going to use one of those strategies you guys showed me. I'm going to skip count by 7s real quick. 7, and y'all can skip count with me. 14, 21, 28. Okay, I got there. So she has 28 square tiles. Now, you guys are going to solve a very similar problem, but while y'all are solving it, I'm going to have jobs for y'all at your table. So at each of your tables, I want you to picture that the person in the desk closest to that corner is person 1, and then we'll go in a circle. That corner is 2, that corner is 3, and then this front corner is 4. So I'm going to give you several directions. Listen so you'll know what they all are. 1, go back to your desk quickly and quietly, not until I say go. 2, you'll look up at the jobs, and as a table team, you're going to work this problem together, going through the steps of the jobs. Okay? So I'll explain more once you're there, but go ahead and go to your table. And their problems are there, right?
Yeah. Where does it flip around?
One of you guys just take a chair to become a 4th person over here.
Ellie just called and she said we're all going to go see Shrek in the cafeteria. She said it's up to us. She said we have a third grader in it. So.
Yeah, that's okay.